Hello, hello. It is time for lesson 5-6, and this is on reflections. A reflection is a type of transformation. It's not a translation. A translation is also a type of transformation. So a reflection, aka flip, it's a transformation in which the figure is reflected in a line called the line of reflection. A reflection creates a mirror image of the original figure. So, think about that. When you look in the mirror, you see a reflection of yourself. You are facing you. When you look in a mirror, you do not see the back of your head. That would be really weird. Sounds like a good movie plot or something. So right here, I have a bicycle again. Here is this line, and basically I'm taking this bike and flipping it over the line. The seat was up top here, now the seat's up top here. The wheels are facing each other. It's like they're looking in a mirror at each other. This line here would be called the line of reflection. So this would kind of be like flipping it over the x-axis, and this would be kind of like flipping it over the y-axis. So again, I didn't just slide the bike over. If we slid the bike over, it would be facing the same direction that it is here. We flipped it over so that here's the front tire, here's the front tire. They're looking in the mirror at each other. So now let's try that with actual shapes. Step 1, can you identify a reflection from a little picture here? So I ask you to tell me whether figure A is a reflection of figure B. So here's my line of reflection. Here's A, here's B. And basically you want to see, does it look like A is looking in the mirror at itself? Does this side length match with this side length? Yeah, it sure does. So I would say yes. And the reason it's a yes is because it's flipped. We didn't just slide it, it actually flipped right over. A nice way to help with reflections, if you're a hands-on kinesthetic person, you could actually have a little cutout. If you have little scraps of paper, we could cut this shape out, flip it over, and see, does that look the same? Alright, when you look at the second example here, here's my arrow. Does it look like this arrow is looking in the mirror? No, the arrow is looking in the mirror and seeing its backside. That would be another weird thing if you looked in the mirror to see. So, this is not a flip. This is a no. This is actually a translation. We just slid this arrow right over. So this wouldn't be a line of reflection. It's just a line now because it's not a line of reflection. Alright, so now what we want to do is we want to do some practice with reflecting figures over the x and y axis. And when we did translations, we were able to see some patterns with our ordered pairs. You're not going to see the same patterns with reflections that you do in translations, but you are still going to see some patterns that make it a lot easier for you. Alright, so first example here, I don't have the shape drawn on for you. It says the vertices of a triangle are, and I list those 3 vertices, those points, those corners out for you. And I ask you to draw this triangle and its reflection over the x-axis. It's important to pay attention to which line of reflection I want you to take. It's either going to be the x-axis or it's going to be the y-axis. And then I ask you, of course, to list the coordinates of the image. So for starters, we want to plot the vertices of our original triangle here. So I am going to list this out because we're going to want to end up doing that in the end. So original, A is -1, 1. B is 2, 3. C is 6, 3. And I didn't just make those up, I got them right there. Alright, so vertice A, I have -1, 1. That's A. B is 2, 3, so that means right 2 on the x, up 3 on the y. And C is 6, 3, so I'm going to go right 6, and then from there we want to go up 3. And now, it's the same day that I don't have my ruler. I'm going to do my best. There we go. Not too bad. So it looks like a triangle, which is good because you were given the vertices of a triangle. So it should look like one. Alright, now I ask you to draw its reflection over the x-axis, and I ask you for the coordinates of the image. So over here I'm just going to write image. And I know I'm going to have an A prime, a B prime, and a C prime. Okay, so when you're trying to do a reflection, we want to pretend that the line of reflection is the mirror. So if I want a reflection over the x-axis, here's the x-axis. So here's the mirror. So if this triangle was looking in the mirror, what it would see would be on the other side. So how I do that, basically I'll take it one point at a time. Here's A. Do you see how A is 1 away from the mirror? that means its image also needs to be 1 away from the mirror in the same position. So this would be A prime. Over here, here's B. B is 1, 2, it's 2 over, and then it's 1, 2, 3 away from the mirror. So its reflection needs to be 2 over and 3 away from the mirror. So that's my B prime. C prime is 6 over and 3 away from the mirror. So you need its reflection to be 6 over and 3 away from the mirror. And put your little prime symbol there. We'll draw it out. And now we're supposed to list the coordinates. So to get to A prime, we have to go left 1 and down 1. To get to B prime, we go right 2 and down 3. To get to C, you have to go right 6 and down 3. Okay, now take a look at these original coordinates and the image coordinates. What's the same about them? Take a good look at it. Do you notice anything that's the same? I'm hoping that you're seeing that all of the x's are the same. So we flipped it over the x-axis. We reflected it over the x-axis, and all of our x coordinates stayed the same. And the reason that happened is because to get to A, in terms of right or left, didn't both of these we had to go left? But the y changed, whether we went up or whether we went down. To get to B, we went the same distance on the x-axis, but in one we went up, one we went down. To get to C, we went the same distance on the x-axis, but we either went up or we went down. That's why those x's stay the same. And notice, here, I went from 1, I have a negative 1. I have 3, I have negative 3. I have 3, I have negative 3. With the image, basically the only thing that changes is the y value is opposite. And again, that happens because here I'd have to go up 3. You're always going to be going the opposite. So instead of going up 3, we went down 3. Up 3, we went down 3. Up 1, we went down 1. So if I didn't give you a picture, if all I gave you were these 3-ordered pairs and I said, what are the coordinates of the image? All you would have to do is say, okay, well, I'm flipping this over the x-axis, so my x's stay the same, and all I need to do is take the opposite sign for the y's. So that's where patterns can really be helpful. All right, now we're going to reflect over the y-axis. So turn your page, reflecting over the y-axis. All right, so now I give you the vertices of a quadrilateral. So instead of having a triangle, we have a quadrilateral. It has 4 sides. And the vertices of a quadrilateral, I'll give you P, Q, R, and S. I ask you to draw this quadrilateral and its reflection, but this time it's going to be over the y-axis. And I ask you what the coordinates of the new image are. So let's list out our original, because again, I want you to be able to see patterns in the end. And we have P, Q, R, S. And given, it's negative 2, 5, negative 1, negative 1, negative 4, 2, and negative 4, 4. So those are all the originals that were given to us in the problem. I'm going to make a little spot for the image as well. And let's plot our original. Okay, so I have negative 2, 5. That would mean 2 to the left and 1, 2, 3, 4, 5 up. That is P, so I'm going to label that with P. Q is negative 1, negative 1. So there's our Q. R is negative 4, 2, so negative 4 to the left and 2 up. And then it says that S is negative 4, 4, so 1, 2, 3, 4 to the left. And then I have 1, 2, 3, 4 up. So again, negative 2, 5 for P, negative 1 for Q, negative 4, 2 for R, and negative 4, 4 for S. Now we just need to connect those. All right, so there's our quadrilateral. It has 4 sides. Wonderful. Now what we want to do is we want to reflect this quadrilateral over the y-axis, because that's what it says we're supposed to do. So again, the y-axis is our mirror. To get to P, I want to stay in the same position, right? I still have to go up 5, and it's 2 away, so I still need to be 2 away, and that's the image of P. Okay, For Q, to get to Q, it looks like we have to be down 1 and 1 away. So there's our Q prime. To get to R, it looks like R is 2 up and then 1, 2, 3, 4 away. So I want to go 1, 2, 3, 4 away on the other side here. And to get to S, it looks like S is, let's see, 4 up and then it's 1, 2, 3, 4 away as well. So 1, 2, 3, 4 away. And we'll connect those and let's take a look and make sure it looks like a mirror image. Does it look like this quadrilateral is looking in the mirror? It does to me too. All right, now to list out the coordinates, because that's what we are supposed to do. Here will be our image. And let's take a look. Before we do any kind of patterns, let's list them out. So for P prime, we go right 2, so that's a positive 2, and we go up 1, 2, 3, 4, 5. To get to Q, we go right 1, and we go down 1. To get to R, we go right 4, and we go up 2. To get to S, we go right 4, and we go up 1, 2, 3, 4. Now take a look. Tell me what's the same. Look at these ordered pairs. What's the same? And hopefully you're seeing that the Y's are exactly the same. 5, 5, -1, -1, 2, 2, 4, 4. The reason the Y's are the same is in the other example, I had to go left or right the same amount. In this example, to get to P, we went up the same amount. To get to S, we went up the same amount. Up the same amount. Down the same amount. So that vertical movement stays the same. But our left-right movement changes. Our left and right movement is opposite. Here when I went to the left, now I need to go 2 right. Here I went 4 left, now I need to go 4 right. So when you reflect over the y-axis, do you see how the x values now are the ones that are opposite? So when you reflect over the y-axis, the y's stay the same. So in this one, all of those y values stayed exactly the same. And the image for my x values became the opposite, which is opposite of what happened with the x's. So now let's try to use these patterns to help us out if you're not given a graph. All right, I tell you in this one, it says, the vertices of a rectangle A, B, C, D, those are all the ordered pairs listed. List the vertices of the image of the rectangle after being reflected over the x-axis. So we learned that when we're dealing with reflections, and again, this only works with reflections. When we were dealing with translations, that's when we could just, if we were moving to the right, add 2. If we were moving down, to take 2 away. With this, we actually have to keep the x is the same when we're reflecting over the x-axis and take opposite y values, or keep the y's the same when we're reflecting over the y-axis and reflect the x values. So because I'm reflecting over the x-axis, that means the vertices of my image, and I'm going to write A prime, B prime, C prime, and D prime. Because I'm reflecting over the x-axis, that means that all of my x's are going to stay the same. Because to get right or left, it stays exactly the same. So I'm going to list all my x values out. In point A, it was a -4, B was -4, C was -1, and D was -1. And if you looked at the example on the previous page where we reflected over the x-axis, we saw that the y's were all opposites. So the circled are my y values. If I'm reflecting over the x-axis, my y values will just be the opposite sign. So that means A prime would be -4 and a +3. B prime would be -4 and a +1. C prime would be a -1 and a +1. And D prime would be a -1 and a +3. All right, one last example, and this time we're going to take the same exact ordered pairs that you were given, but now I want you to list the vertices after we reflect it over the y-axis instead. So I'm still going to have my image A prime, B prime, C prime, and D prime. Now remember, when you're reflecting over the y-axis, the y values were the ones that stayed the same. So when reflecting over the y's stay the same. So that means for A prime, my y is still going to be -3. For B prime, my y is still going to be negative 1. For C prime, my y will still be negative 1. And for D prime, my y is still going to be negative 3. So again, when you're reflecting over the y-axis, the y values all stay the same, because picture that. You have your line of symmetry, your line of reflection, and it's this vertical line, and when you are looking at reflections, you're still going to go up or down by the same amount. It's the left or right that changes. So that's why on the x values for this, when we're reflecting over the y-axis, the x values will all be opposite. So the original x value in A was negative 4. That means in my image reflected over the y-axis, it's going to be a positive 4. For B, it was a negative 4 originally. Now it's going to be positive 4. For C, it was originally x was negative 1. Now it'll be a positive 1. And D, it was originally a negative 1. And now it's going to be a positive 1. All right, that's enough for today.